Okay, we are live again. Welcome everybody to yet another session for the Alchemy Conf virtual edition. Right now, we're going to have Ben Smith. He's going to talk a little bit about business domains, events, and I'm guessing everything from event storming to event sourcing and somewhere in between. Ben, welcome. I'm going to leave now.
Thanks for the intro. So let me just quickly share my screen and then I'll begin. So hopefully everyone can see that now. So today's talk is going to be about modeling complex business domains with events. So I think this is applicable to Elixir developers in particular, because we're used to building applications where we're thinking about messages that get passed between processes in our code. So the idea of modeling our business domain using events is just to take that message passing at a higher level, at the application level, where we're thinking about the messages that gets passed between different processes in terms of commands and events, are the two particular types of messages that we're going to be dealing with today. So a quick overview of the talk, the three different parts. There's going to be a brief introduction to what domain events are. Then we'll go through how we could model a complex business process with our events, and then how we could implement that model in Elixir code itself. So let's start by answering the question, what are domain events? So if anyone's unfamiliar with this concept, it comes from the domain-driven design, the book really that was written by Eric Evans, and also the practice of using domain-driven design to build software applications. And the domain event is something that's a record, a fact, if you like, of something that happened in a business domain, and it's immutable. So once you've recorded domain event, you can't go back and change history because that fact has been recorded. And the canonical example is in accounting, where we have double entry bookkeeping. Every transaction is a credit and debit inside a ledger. And then at the end of each financial year or each accounting year, you sum up the totals for the debits and credits to get the closing balance, and then you copy those across to the next year's accounts as the opening balance. Then you record the transactions as they are made, and you typically don't have accountants going back and making changes to historical ledgers. They would go and add compensating transactions which undo, if you like, the mistakes. So if you have an incorrect debit, you would then reverse that by adding a compensating transaction to undo it. And these domain events are always supposed to be named in past tense because they're things that have happened in the past, and they should be in the language of the business, i.e. anyone from the company, whether they're a technical person, software engineer, tester, product owner, product manager, someone from sales, marketing, anyone in the business should be able to look at these events, and they should understand them because they're using the language of the business. So some examples here from a fictional e-commerce application might be item added to cart, checkout completed, payment taken, order dispatched. So you can look at those events in the event log, and you can actually have an idea of what happened. How did this order go from adding the items to the cart to payment taken to dispatching it to fulfilling that order, so from end to end. And this gives us a few benefits of when we come to look at how we might debug these issues, because we can go back in, look at the log and see exactly how the current state, the events that led us to the current state. So they're useful from a debugging diagnostic purpose, but also businesses can derive insights from these events, because you can go and have a look at what happened in the past to make predictions about the future. So one example might be, if you see that someone adds an item to a cart, later removes it, they might still be interested in that item. They just haven't, for whatever reason, fulfilled the checkout yet. So you could send them an email notification to say, hey, you were interested in this item. If you complete your checkout now, we'll give you a 10% discount on the order within the next 24 hours. And we can also look at how different actions by users can affect the business. So we can look at whether particular items that go on sale, for instance, convince people to check out more quickly, or we could have a look at the kind of time elapsed from a checkout being completed to a order being dispatched or fulfilled. So having these business relevant facts recorded in an immutable historical log can be very valuable from both technical perspective and also from the business perspective. And when we talk about event-driven systems, there are three types of classifications of the events that we might be talking about. The first one is event notification, where it's a kind of pub/sub notification where something happens within your application. So an order may be dispatched and you just publish a domain event to say, hey, order dispatched, order ID 1234. And then any interested system or service or process that might want to know about that information can then go and look up the information about that order from wherever it needs to go to. Or it could just be used to trigger some downstream processing. So it could be an instance of making sure that the products are in stock in the warehouse or preparing the dispatch of an order. And then the second level is event carried state transfer, where you have these notification events being enriched with more information from the business. So if it was a order dispatched, or let's say it's a checkout completed event, that event may contain all of the line items for the order, including the price, the delivery address, the customer's address, maybe their billing address, and the particular payment method they've chosen, so that the systems that are reacting to that information don't have to go and look up the data, they can just read it from the event itself. And then the third type is event sourcing, where we use the events that get recorded as internal domain events. They're used to build the current state of the application. So an example of why we might want to do this is because we treat the event log as the source of truth for the system, and any other view of that data is derived from those events. So the events get projected into different read models that are designed for querying for different types of purposes. So you might have a SQL database, which is used for showing information on screen. You might have a document DB used for reporting. You might project into a full text search index to provide searching capabilities. You might project the events into a some kind of analytical database or offline database, which is used for doing kind of business type analysis of those of the application. So the idea is that the events are immutable facts, and then you can represent the information from those events in different ways by projecting those into different types of data models, different shapes that are designed for particular querying needs. So if we decide that we want to model an application with events, we then ask, how can we do that? So one modeling tool that can be used is called event storming. And the idea of this is that you have different colored sticky notes that are used to represent different types of building blocks, if you like, in the event storming world. So the one we've seen before is the domain event, which is the orange sticky. And then domain events have to come from commands, which are instructions to do something. So if I want to buy an item, I'd click the button, pay now, and that would be a command to the system. And an event may be triggered and recorded from that command. And the actor is the person or the thing or the system that's requesting the command. And then we have an aggregate, which is used as the thing that's the consistency boundary or the transaction, where commands come in and events come out. And then we have external systems, policies, and read models. So read models are the way of viewing to one or more domain events, and a policy is a kind of a business process or a workflow or something where you have a component reacting to domain events and instructing the system to do something else. And in event storming, there are two different types of sessions that you can hold. One is a big picture event storming session where you bring together everyone involved in the business, so technical people and non-technical business domain experts, bring them all into a room. In pre-COVID times, you would all gather together in the same room. You'd have a whiteboard or a large wall and the real sticky notes, different colored sticky notes available with pens, so that everyone can draw up the sticky notes and stick them onto the whiteboard. And the big picture session is all about trying to share knowledge of the business process that you're working on. So it's the outcome is that everyone has a same consistent model in their head of what the business does, uses the same language, which is a very important tenet of domain-driven design, where technical and non-technical people in the business use the same terminology to refer to the same thing. So you don't have to have a translation between when Bob says foo, when Bob from the business says foo, the technical team have to translate that to bar, because bar is what's referenced in the code base. So the idea is you use the same terminology throughout, so that when someone says something within a particular business context, everyone understands what that word means. And then you have the design level event storming session, where you actually drill down and try to come up with a solution to a particular problem. So you have the big picture is information that we're sharing, and the design level is where drill down into a smaller area of the big picture, and we'll try to come up with a solution to a business problem that we could then take and map that into working code and deploy it. So one is about sharing knowledge, and the second one is about actually trying to come up with a solution to a problem. So let's have a quick look at how we could do a big picture event storming session. So because of the COVID situation, we can't all gather in a room and do this with sticky notes. So we have to do with using an online tool, collaborative tools such as Miro, which I can recommend because it has all of the different colored sticky notes, which are ideal for doing this kind of session. And also it can be done collaboratively. So more than one person can be adding sticky notes and typing and editing at the same time. So the big picture event storming, we're only really interested in domain events. So the orange colored stickies, and there aren't that many rules in how you run these sessions. There are guidelines. One of them is that time flows left to right. So if I'm adding an event, if it's to the right of another one, then it typically comes after it. So that's almost the only real rule in terms of the big picture. And we have to remember that domain events are named in the past tense because they're things that have happened. So it would be item added to cart would be a good example. And for this session, I'm going to go through a fictional application. We're going to re-implement or do an event storming session for an online auction service. So think of eBay, which I hope most of you are aware of. You have sellers who are listing their items for sale, and then you have people who are bidding on those items, and the auction has a start and end date. And at the end of the auction, the highest bidder wins, and then that person is committed to buying the item. So they're the buyer, and they have to pay for their item, and then the seller dispatches it, and there's a feedback mechanism. So if we were to build an online auction service, we would start off with a big picture event storming session, just so that everyone in the team knows the concepts involved, the business domain, and also we start to work out what terminology we want to use for the different types of the different pieces that we're going to be building. So with an event storming session, we can start at the left, at the beginning of a process. We can start at the end, or we can start at the middle. Doesn't really matter. We just need to choose one place to begin to start the process from. So we could have a item listed as just one event that I throw up on the board. So that the first phase is normally called chaotic exploration, where everyone has their chance to add whichever domain event they want. So we just literally try to go through and think of all of the particular events that are relevant to this business process. So we have auction started, we have an auction ended, we might have we could have an item sold event near the end. And we could also model that would be the happy path. So we might have a item unsold event, because that would be the case where something hasn't been sold. We also need to have people bidding on the auction, so we could have a bid placed. And one thing that you may or may not be aware of with services like eBay is that you can have automated bids being placed for you. So when you choose to bid on an item, if the current price is £10 or equivalent currency, if you're willing to go up to 15, when you place your bid of 15, eBay will only put the bid at say £11 or £12, so that it just does the next level up from the current bid. So that would be so that if someone else comes and bids £13, then it will place an automatic bid for you up to £14, up to your maximum. So we have the idea of a bid being placed by a person, and then an automatic bid being placed by the system. And then once an item gets sold or is unsold, we might have payment. It needs to be made by the buyer. So we could have a payment requested as an event, and we could have, so one of the benefits of using a tool like Camiro is that it's pretty easy to move the sticky notes around. More difficult with a real whiteboard, but not impossible. And so we could have item dispatched or item delivered, item dispatched. Yeah. This is a rather synthetic example because I've already thought about this, the events that come up here. So there's less of the chaos and more of the, I've already thought through this, so I'm kind of just typing out the events. But even so, it hopefully gives you an idea of what the process is, because I find that when someone talks about event storming or these types of modeling techniques, if you haven't seen it in practice, it can be quite difficult to understand what's going on. So one of the benefits of using a tool like Camiro is that we can drag and drop arrows between each of the different sticky notes, because when we move a card or a sticky note, the arrows move with us. If you were to do this on a whiteboard, if you draw arrows between the stickies, then it kind of locks the design in place, because when you move a sticky, the arrow doesn't move. So it's normally frowned upon to have the arrows joining the stickies when you're doing it on a whiteboard, because it kind of locks the design in place, if you like. And for an online auction service, one of the most important things is that once an item has been sold, we can determine what the commission is that we're going to charge. So this is we call it item final value fee calculated. So this is where the system or the application makes its money. So this is probably, in terms of the business process, this is the most important event, because this is where the online auction service makes its money. And then obviously once we've calculated the fee, we can charge the seller. So it will be, the event might be captured as final value fee paid. So this is very brief idea of what a big picture event storming session is. So the chaotic exploration phase is you throw all of the events onto the board that you can think of. The second phase is you enforce the timeline. So this is where the time flows left to right. So it wouldn't make sense for me to calculate the fee before the item's been sold, because that could never happen. The fee has to be calculated after the item is sold, because it's only the final selling price that determines what the fee is. The next part of a big picture workshop is to think about the people and the systems that are involved. So when we request payment, we may need to interact with a third-party payment gateway. The same when we do the final value fee paid. So we might have to think about how the payment requested would then require a call out to a third-party payment gateway. And also we can think about the people involved. So I spoke before, we have a seller lists the item, and then we have people bidding on, buyers or potential buyers bidding on the item, and we have the system placing automatic bids. And one of the strong points of a event storming session is that it takes advantage of our inherent preference for storytelling. So what that means is that we can run through the events by telling a story. So I could start at item listed, auction started, bid placed, auction ended, item sold. That story makes sense. I could also work backwards. I can say, right, item dispatched. Before an item is dispatched, we must have requested payment. Well, actually, we have a problem here, because we only want to dispatch it when a payment has been made. So we can see that when we use language, we can identify where there are gaps in our story. So one of the traits of event storming is that you just use natural storytelling to identify where the problems are, and you can run through the events forwards and backwards to tell the story. And also we can identify where there are any problems and opportunities. So I can say one thing that might be difficult is we need to integrate a third-party payment gateway here. So by putting the stickies on the board and by decorating them with any problems or opportunities, we can immediately see where the complexity lies and where there might be areas that we need to drill down, and we can find where there are gaps in our understanding. If we had two people coming up with the different terminology for the same event, then we could have a discussion as to what we agree on as a team for the terminology. So here I've called it item and auction as two of the key components, and then the final value fee is the way that the service makes its money. So this is quite important. So maybe I want to highlight that prioritize this, because this is the part that makes us the money. So that's the big picture event storming. If I quickly switch back to my slides. So here's the same diagram that I came up with earlier. So you can have the happy path. I like to do the happy path flowing horizontally, and then the kind of unhappy or the sad path diverting off. So after an auction gets started, it may be cancelled by the user, and then it will be ended, and the item may be unsold. So an opportunity arises here. So when I spoke about problems and opportunities, when an item is unsold, whether that's because the auction ended and there were no bids, or because the seller cancelled the auction, we could offer them the opportunity to relist it for free. So that might be a way of driving more business value for the service, because we can say, right, your item didn't sell this time. How about we offer you the chance to relist it for half price fees, or maybe you should relist it with a slightly cheaper opening price because it was too expensive. And then there's another little service hanging off here, which is the feedback requested and feedback left. So you can take the takeaway from this modeling process is that everyone now understands what problem the business is trying to solve, the terminology that everyone should be using, and they should have some understanding in their heads as to where the problems are or where the opportunities are. So the second type of event storming session is the design level event storming session. And this one involves drilling down into one of the problems or one of the areas from the big picture and actually trying to build a solution to the problem. So here's a diagram of all of the different colored sticky notes that are relevant. So the one that we've been interested in so far is the event, the domain event, which appears in the center here. And you can see that a domain event can trigger lots of things reacting to it. So one of the ways that an event can be produced is from an aggregate, and an aggregate is a consistency boundary or a transaction. So if we think about when we have two auctions running for different items, those should be those can be two separate consistency boundaries, because someone bidding on an auction for one item doesn't affect another person bidding on a different auction. But two people bidding on an auction for the same item, that should be consistent, because we need to work out who's the highest bidder. So there may be some timing issues around that. So therefore, we would use something in the Elixir world, we'd use something like a gen server to make sure that requests to a single aggregate instance are serialized in the message queue and process one after the other. And I spoke before about commands. A command is a way of instructing the system to do something. So place bid would go to an aggregate, and then bid placed could be the event that comes out at the other end. And then when we want to interact with an external system, we would use an event handler which just reacts to that event, and then can go and call to an external system. So it might be a payment gateway, it might be a job queue, it might be a scheduler, it could be any third party's service that needs to be integrated with, it could be another internal system that needs to be integrated with. And once that request has been made, then the outcome of that request, whether it's payment being requested and succeeded or not, we can feed that information back into our system as either a command to say, yes, payment was successful, mark it as paid, or mark it as payment failed, or we could actually record it as an event from the external system, and then we could use another event handler to react to that event and then process that however we like. Earlier on, I spoke about how do we deal with querying data from events. So we don't typically want to look at the event log, because it's hard to interpret those. It's hard to interpret those events on the fly. What we really want to do is have another specialized event handler, which for each event that it receives, it wants to copy the information that it's interested in into some projection, a read model projection. So that could just be a SQL database, or it could be any other data store that's designed for answering a particular query. So that that query might be coming from an API. So it could be a REST API, GraphQL, any other type of API, or it could be shown on screen to the user as some UI. So we could have a list of active auctions, and there could be a projector which is listening for the auction started and auction ended events, and it just projects those events into a list of the active auctions. And then that could be shown on screen to a particular user. And when the user sees that information on screen, it can react. The user can make a decision, and they can click a button, or they can do something which then would send a command back into our system. And the command would then go to an aggregate, could create an event. It may be rejected, and the event then triggers the other processing. So it's a completely reactive system. And finally, we have this idea of a process manager where it reacts to events and it sends commands. So the reason for having this is because the consistency boundary is just an aggregate. And if you need to make a change across more than one aggregate, you can't include multiple aggregates in a transaction. So what you have to do is rely on eventual consistency, where you would send the command to the first aggregate, an event would pop out, the process manager reacts to that and sends a command to the second aggregate, gets back an event, and then can send a command to another aggregate, gets back an event, and so on. And if any errors happen, then the process manager knows it did commands A, B, and C succeeded, D failed, so I need to undo the changes that I made in C, B, and A to get back into my original starting state. So the process manager can basically implement a distributed transaction, but it's using eventual consistency. So there isn't a begin, do this, this, and this, end, commit. It's a do this. If that failed, do this. If that failed, try to roll back the first one. So it's more of a manual process. So if we go back to what we are trying to do with our auction service, so we can start very simply with, if I copy the command and the aggregate and event from here down to here. So the first event that we can start modeling is item listed, and I'm going to call our aggregate item, and then the command very simply is just going to be called list item. And I can also copy, if I scroll out slightly, I can copy, actually, if I move this up here, we can see the key. I can copy the actor, and we know that the actor in this case is going to be the seller. So we have our first command produces our first event, item listed. And we know that when an item gets listed, it will have a start and end date that will be used for creating an auction, or determining when the auction is active, if you like, when people can bid on the auction. So I might have an event handler that listens out to these item listed events and will schedule a command at a later date to actually start the auction at the appropriate start time. So we might have another set of commands for an auction. And it would be the event that we had before was auction started. And this will be start auction. I hope everyone can see the screen okay. Zoom in slightly. And this would be a system command, because it's an automated command, if you like. So we have our first listing an item, and then later on, when the start date is due, we start the auction for that item. And then if we want to display on screen a list of active auctions, or sorry, a list of items for sale, we need some kind of projection of that. So we could have I call these summaries, just so that it's obvious that this isn't our model that's used for writing. This is a separate model used purely for querying. So if we need to make a change to the item, we don't modify the item itself. The item summary, we don't modify that. We would have to dispatch a command to update the item. So the way we would do that is we might have a separate command called revise item, and that would create a item revised event, and then that event would go and update the summary. So that second event, whenever we make a change to the item, that would then feed back into the summary to update what's shown on screen, or as part of a response to an API. So if I move on to just try and look in my notes, because I've I've gone through this process already just to make sure that it's not completely chaotic. So we've listed an item, we've got the ability to revise it. An auction has been started for whatever the particular start date was for the item. Now, if we have a look at placing a bid on an item, on an auction. So the first one, I've just added a little note here so that we can remember, we know what we're doing. So the first scenario will be, this is going to be the first bid on an item. So we have no previous bids. And the command is going to be place bid. And we have bid placed. And we may want to have a notification that we can send out to say, hey, congratulations, you're the highest bidder. So I have an event handler, which is some highest bidder notifier. So that could be an email that gets sent, it could be a text message, it could be an in-app notification, it could be if the user's still browsing the site, it could be a notification inside the site itself. And we'd also probably want to have a way of viewing the auction. So we can have an auction summary here, which might display information about the item that's for sale, plus the highest bid amount and who the highest bidder is. So that's an example of doing the first bid on an item. So slightly later on, a second bid comes in, and we'll say we have this higher bid has been placed. So again, this isn't the system. This is going to be bidder one, and then we have a second bidder coming in, and they're going to do the same. They'll place a bid, and then we're going to say that they are now the highest bidder. Oh, sorry, I missed. Let me delete this one. We're going to have a second event now to say that they are the highest bid. They have the bidder 2 is now the highest bid, and we can have this. We can notify them, and we'd also might have a third domain event to say that bidder 1 has now been outbid. So we could have a bidder outbid event. And we might also want to have a second notifier for that event to say, hey, sorry, you've been outbid. Come back to the site and increase your bid if you want to win the item. And these may also all feed into the summary. So we have a bid being placed. It's the new highest bid, and our original bidder has now been outbid. So we've captured these as domain events. So if I was to look at the event log for an auction, I could see exactly what happened over time, and it would be these events would be very useful for me to be able to track when something goes wrong, or if I wanted to answer the question, hey, how did this person end up winning that auction? So now if we go to a third scenario, and this is going to be a scenario where an automated bid is placed by the system. So this is going to be bidder 3. So we might have a bid placed, and then instead of being the highest bid, there may be an automated bid gets placed by the system for the second bidder, because their highest bid was actually higher than what the person originally, what the third bidder wanted. And that would probably feed into here as well. So we have bid being placed, an automated bid placed, that becomes the new highest bid. And then again, we have this bidder outbid. So we have domain events tracking each of the different changes of the state of this auction. So we track the original request that came in as an event. We're tracking the fact that the system has placed automatic bids for us. We're tracking who has the highest bid so that we can then notify people that they're the highest bidder. And we can also have events that track when someone gets outbid for an item, and we can notify them as well. So we kind of have the events not only track the state changes, but they can also be used for driving reactions in the system for other features. If I quickly switch back to my slides. So I've just gone through, and these are the processes that we've just done. We might have a process around when we end the auction. So we could have the auction scheduler kicks in again when the auction was due to end, and it can send a command to end the auction. The auction ends, and if there was a highest bidder, we can then track the fact that the auction was won, and we might have a notification to say, send an email to the winner to say, hey, congratulations, you won this item. Please, can you make payment? Once the auction's ended, we have this process manager to then go back to our item and mark it as sold. If there was a highest bid, we might mark it as unsold if there were no bids, or maybe it didn't meet the reserve price, which is another feature that we might choose to implement. And then we could have a sold item notifier and an unsold item notifier. And when an item gets sold, we might then have another process manager to actually request payment via some third-party payment provider. And again, when we request payment, there might be a notification to say, click here to pay now. And then we can track when we make a payment, we can track that the payment was made, and we could track successful payments or failed payments, and then we could react to those ourselves as well. And I went through this earlier. If we have an item that's unsold, this is an opportunity for us to offer a relisting of an item as a way of getting people to continue using the service rather than having an unsuccessful outcome, which is their item didn't sell. We can say, we'll offer you the chance to relist the item for free or maybe reduced fees. And so we offer that to the seller. And then the seller may choose to click the button which says relist item. And then that goes through the same process of scheduling another auction to occur whenever the seller wishes to. And then if we look at the design level process in its entirety, we can see that the general flow of all of the different building blocks that we have in the application. So that you can tell where the complexity is or where the branching is. And you can kind of use this to understand how much effort is involved in building the application that you've spec'd out. So you can kind of take each of those stickies and you could just say, well, if we say that each sticky is 1 day's worth of development effort, we can then quickly tot up all of the stickies we have and say, right, as a rough finger in the air, we have 50 stickies, so that's 50 days worth of effort. Or we can go back and we can put this design to one side and say, we're going to come up with a different solution to the same business problem, and we'll see if that's a preferable solution or not. And we all know that it's far easier to spend an hour at a whiteboard modeling than it is to spend 2 or 3 weeks writing the code only to understand that you've made a mistake or there would have been a better way of doing it. So the value in doing a design level event storming session is that moving sticky around is very cheap. It's much cheaper than moving code around. And once you have all of the stickies created, you can then take those forward and actually start building the code to implement each of the features. So once I come up with my design level event storming session, or once I've done that session, or maybe I've done multiple versions of that session, one session for each of the different areas that I'm interested in building, the next question becomes, how do I implement that model that we've come up with in Elixir? So here, there's a open source library that I've built called Commanded, which is designed for building event-sourced applications. So CQRS means command query responsibility segregation, where you have 2 models instead of 1. So you have your write model, which is the events, and you have a read model, which are the projections. And changes go to the write model and are projected into the read model, and the read model is used for querying. So you can use Commanded and EventStore, which is an event store for Postgres, and the Ecto projections library, which is for doing the read model projections with Ecto. And then Commanded generator, application generator, is something that I built for the talk today to show how you can take a commanded application and you run one small command and you point it at your Miro board, and it will scaffold you your application structure, which has all of the dependencies wired up and configured in it, and it builds modules for each of the different pieces. So structs for the commands and events. It will create the event handlers, the read model projections, plus their Ecto schemas, the aggregates, and the process managers. So if I quickly switch to share my terminal window, if I can do that. So hopefully, if I zoom this in slightly. So you can see I have this mix commanded new auctioneer and passing it to the Miro board. So this uses the Miro API to go ahead and create all of the different modules, the Elixir modules that I'm interested in. So if we look at some of this, you can see that there's an auction folder which has some events in that we're familiar with. So bid placed, highest bid, bidder outbid, has the corresponding commands, start auction, end auction. It's a separate one for the item with its commands and events, third-party payment, and then we have the event handlers, so auction, scheduler, the notifiers that I included in my diagram. Then we have the process managers for doing the payment and the selling, and then we have the projection, so the auction summary and the item summary. And if I go and open that inside a text editor, I can quickly share my screen. So we can see we have the scaffold, if you like, in place where inside our auction aggregate, we have the functions where we can react to our commands and return events. So in Commanded, the idea is that the execute function takes in the aggregate state and the command, and you need to return the events. So in this case, the start auction is the command, and the event that corresponds to that would be auction started, and then we would copy the auction ID from the command, and we would copy across any other information from the command that we want, and then we would just return OK and our event. And then once we've returned the event, to do the event sourcing approach, we need to update our aggregate state from the event. So we get past the current state and the event. So the way that we would update this is to standard Elixir code here. We would copy that from the event. So this is just a very simple example, but I'm just showing you the kind of two-step process for aggregates in Commanded. You have the execute function, which takes the command in, returns the event, and then the apply function takes the state and the event, and then it modifies the state. So the apply function is used every time you want to start the process. You load all of its existing events, you call all of the apply functions for those events, and then you have the aggregate state rehydrated. So that means that when the process gets stopped and you start it again, you can go back exactly where you were because you just replay the events and call the apply function. So the commands and the events are just plain Elixir modules. So you would add the additional fields here. So we probably have a start and end at time for our auction, which we will then copy across to the event. So we have start auction as the event, and then start auction was the command, auction started was the event. And by default, the events get serialized using JSON. So if these are date time Elixir types, then we would need to decode those from the JSON inside this decode function. And then there's built-in support for upcasting. So by default, the event starts at version 1, and then it would go to, you can upcast it to newer versions. If we added or removed fields, we could then handle that versioning. And if I have a look over on the handlers, we might have look at the auction scheduler, for instance. So this is an event handler which processes or gets sent each of the events, and it can use pattern matching to pick out the ones that it's interested in. So we said that when an item gets listed, what we could do here is do something like we have some kind of job queue where we can enqueue a function. Maybe you want to say start auction, and the item ID might be the argument we pass, and then we need to copy across the item ID from the event. And then, or maybe whatever our job queue library does, we tell it to run at whatever the start date was for the auction that we've determined. So this is the way that you would interact with internal systems, or you would do any kind of side effects. So one of the side effects might be to do the remodel projections. So Commanded provides this project macro in the ecto projections where you get past an ecto multi-struct, and you can again use pattern matching to react to any of the events that you're interested in. So we might want to create our summary, and then we can use the ecto multi functions to insert our item summary, which, if I show you on the item summary, is just an ecto schema that I'd have to add in whatever the fields I want in here, field, start at, etc. So then that projection only ever gets modified by one of these projectors, where we listen for events and project them into the read model. And then final thing, we have this concept of the process manager. So again, it uses pattern matching to react to particular different types of events that it's interested in, and then it can dispatch commands. So so the command in this case, once the item's sold, the command might be called, if I look under the third-party payment, the command might be request payment, and then the fields or whatever. So when the item gets sold, the next thing we're going to do is, as a reaction to that, is we're going to request payment for that item, and we pass across any information that we need. And then the third-party payment component can deal with actually making the request to the payment gateway for us and reacting to that appropriately. If I switch back to sharing my other window. That's just an example. Okay, so if you're interested in learning more about event sourcing and CQRS with Elixir, then you can go to this awesome Elixir and CQRS list that I've created. And if you want to get in touch with me, then there's my email address and my website for any questions that you might have. Feel free to ping me a request. And I think that's all that I have to cover today. Questions?
Yeah. So first of all, thanks for the talk. I really enjoyed this last little bit. It would have saved us, I think, a lot of time when we were using Commanded more. One thing I'll start with that is that Miro thing, the generator. Will it have support for attributes anytime soon?
So you mean if you wanted to do something like, it has support for doing something like this?
Okay, yeah, that's exactly it.
So yeah, I haven't really gone to town on that, because as soon as you start adding things like support for attributes, which it does support this kind of, I can't remember if it's a dash or a star, but then you kind of want to say, actually, we want to specify the type of this. So maybe we want to say that this is a integer. So you can kind of, the limitations of using the sticky notes starts to come in then, because there isn't really enough space to do all of that.
Yeah.
But yes, there's definitely has the ability to then to do things like that, start at and end at, etc. Yeah, so the main thing is that it can take some time to configure all of the different parts of the application in terms of commanded EventStore, projections, the application, the router, the aggregates, the events, and the commands. So it's the main reason was it just scaffolds you the kind of bare minimum, and then you go and fill in the blanks. So the other nice thing is that if you make a change to your event storming model, you can run the generator again, and you can choose to not overwrite stuff that's there, but then just add the new things. So it will add the new events and commands or handlers and projections. So you can make changes to the model, and you can make additive changes to your event storing model, and then you can apply those to your code base. So that would be quite a nice feature as well. So I think the main takeaway is that a couple of hours spent modeling it using event storming can save you weeks or days worth of development. So that's pretty much all of the codes that I've been writing over the last few years I've gone through at least one event storming session to just come up with an idea of the model before I start writing any code.
That's good. That really ties up into the first question that we have here, which is if there's any cases where event storming is not a good fit to model domains.
I'd be biased and say there is none, but of course that's not true. And there are. So I think the talk of the subject of the talk was complex business processes. So if you're modeling if there's some complexity involved, so the example that I used of the online auction site didn't have too much complexity in it, but it needed to be simple enough to just go through in a talk. But normally you have more complex domains where it's often hard when you have reactive code to understand the overall picture of how things fit together. So having a visual diagram of the application can be very helpful to say, right, when this happens over here, it kicks off this downstream processing chain, and this kicks off this other processing chain, and there's this branching, and then it can feed back onto itself. So I guess the more complex domains benefit from using the kind of event modeling approach, event storming approach.
Mm-hmm.
So if you're building something that's relatively simple, then there's probably less value in it.
Another question is, so when you're modeling events, but you're starting a company project, whatever, you're just also learning about the problem. And so you don't know that much probably. How often and how do you remodel? So instead of, I'm assuming it's just not all big design up front, and like how do you make it iterative?
Yeah, I think so. The kind of big picture event storming session is very useful near the beginning of a project or starting a company, because it's trying to get everyone on the same page. And you can do a big picture session for the entire business process, or the entire company, or you can just focus in a section of it. So you could say, in this example, we were just interested in listing an item and selling it and doing the auction process, rather than registering users, having to deal with that kind of stuff. So I think you can come back, and once you've learned more about the business domain, you can come back and do another session. But I guess that would be the design level sessions are more of the things that I'm starting to build. I need to start work on a new feature. Let's do a design level session for that feature, and then we'll build that, and then we'll move on to the next business process or big feature, and we'll do another design level session. So they're often done at the start of let's say you have a chunk of work that's going to take you a month to do or 6 weeks to do. You would do the design level event storming session at the start of that, and then when you move on to the next piece of work, you'd probably do another one. And then, because often you have the pieces of functionality are one leads on to another one, which leads on to another one. So you don't often have to go back and rework it.
So quick question here: is the Miro board you used public? And so maybe share it on the chat if you want to make it public.
I don't know. It may.
You can check it afterwards. But if you want to make it public, then maybe put it on the chat here and people can access that.
Yeah.
And I'll just another last question here before we have to go is so how many stickers are there in a regular project at the design phase, and what's like the biggest one you've worked on?
No, I'm not sure I've been keeping count. Yeah, I don't know. So before COVID meant that we all had to stay at home and away from each other, I did this process for a number of different companies, and often you would, talking about a day's worth of doing big picture event storming session in the morning, and then do maybe a design level session in the afternoon and the next day. So you'd get through a decent amount of stickies, just because one of the benefits of the modeling process, a visual modeling process, is you can come up with multiple solutions to the same problem because it's cheap to throw away. At the end of the day, they're just stickies. So the investment is the time. The investment is because you're getting a shared understanding of the problem and coming up with a solution. So you can use as many stickies as you want. Often when you do the big picture, people will throw up the stickies at the same time, and they'll have stickies for that, they'll put stickies together that have different terminology on them. So part of the value is that discussion is, hey, you've called it this and I've called it that. We should really come up with a consistent terminology. Or we could say, actually, these two things are differently named because there's a system boundary here, and it's named this in this system, and there's a context switch from that system to this other system, and therefore we've identified a boundary. So that can be a useful takeaway, because we can say, right, let's break our services to say everything to the left is going to be service A and everything to the right will be service B. So that's one of the good outcomes of the design of the big picture of session, is you can find these what they call pivotal events, where you switch from kind of one process or one system to another, and then you can have a nice clear boundary to say, hey, we call it this over here and we call it something else over here, but that's fine because they're two different contexts.
Yeah. Okay, I think we're out of time, but thanks for the talk. One last thing, someone here is plugging the book you wrote called Building Conduit. So just plugging that on your behalf.
Thanks. Yeah, that is free to read online. If you go onto LeanPub, you can read it online, and it's takes you through step by step how you build an application using Commanded with Phoenix as well.
Okay. So again, Ben, thanks for being here and for the awesome talk.
No problem. Thank you. Glad to share. Bye-bye.